In the previous movie, we added the ability to scale the no-flip leg non-uniformly and connected the visibility of the controls to the current IK-FK blend mode. In this movie, we'll clean up our leg rig according to our checklist. Start by opening the file Character Rigging, Part 18 Start, or by using your own file from the previous lesson. So far we've confirmed our controls are easy to use. We also know from the work we did in Part 12 of the series that the local rotation axes are set correctly for all legs. A quick check confirms that the values for both the leg and foot rigs are zeroed appropriately, and that the rotation orders are consistent. The next thing we should do is hide anything we don't want the animator to touch. First, select everything related to the leg and foot and group it into a left leg group node. Make sure that you don't include the settings group. Parent this group to the Emma root transform control. Next, take all the distance nodes, start locators, IK joints, and result joints, and group them under a Do Not Touch group. We're going to hold off on locking and hiding attributes for the time being, and instead work on getting the leg to move in conjunction with the rest of the body. The reason for this is because we're going to need these attributes available for our constraints. Group all the measurement start locators along with all the IK joints into a left leg IK const group. Likewise, group the result joints into a left leg result const group. Set the result skeleton layer to reference mode and point snap the pivots of both these groups to the thigh joint. Notice that if you select both groups and translate them, the leg moves from the thigh. That means all we need to do is constrain these groups to the hip bind joint, which is the key joint controlling the base of the spine. Create a new locator named left leg hip space loc. Point snap it to the thigh joint and parent it under torso group, do not touch group, hip bind joint. Now point constrain both the left leg IK const group and left leg result const group to the space locator. Next, we'll do the same with the FK leg. Switch over to FK mode. Recall when we were connecting the FK neck to the body in Part 9, we allowed the head to move in various spaces. We'd like to do the same thing here. First, create a group for the FK leg chain named left leg FK const group and move its pivot to the thigh joint. Like the IK leg, point constrain this group to the hip bind joint. The FK leg follows the hips as expected. Unlike the head, this is the only translation space we need to cater to, since the leg is directly attached to the hip. Conversely, we will want the ability to switch the leg's rotation between hip space, upper body space, and root space. Since we already have a locator for the hip space, duplicate it twice more and rename the duplicates left leg body space loc and left leg root space loc. Reparent each of these locators under the torso's do not touch group and the Emma root transform control respectively. Select the space locators in the order we created them, and orient constrain both the left leg FK const group and left leg result const group to them. Now add a rotation space attribute to the left leg settings control. Set the data types to enum with the 3 spaces as options. Open the set-driven key window. Use the left leg settings control as the driver, and both the left leg FK const group and left leg result const group orient constraints as driven. Set the weighting in each mode, just like you did with the neck in Part 9. Everything looks like it's working great. However, try twisting the hip, then switching back to IK mode. The leg is now completely offset from the foot control, which makes it unusable for the animator. The problem stems from the fact that we orient constrained the result leg to the space locators according to the FK rotation space. However, because the IK leg also uses this result group, the effect is bleeding over and causing problems even when we're in IK mode. What we need to do is blend the result group between the FK orientation space and the IK space. Then we'll control the blender attribute by connecting it directly to the settings FK-IK blend attribute. Select the left leg result const group and open the node editor. Show the connections. Create a blend colors node and rename it left leg result orient choice. Connect the left leg result const group orient constraints constraint rotate attribute to the blend node's color 2 attribute. Set color 1 to 0, 0, 0. Now connect the left leg settings controls FK-IK blend attribute to the blender attribute. Connect the output of this new blend node to the rotate attribute of the left leg result const group. Now the leg is affected by the orientation spaces in FK mode, but not at all in IK mode, and we can blend nicely between them. Once you've tested the various modes adequately, lock and hide all the newly created group nodes attributes, and hide the space locators. Next, we need to make sure our leg works within our rig's root transform. If you try translating and rotating the root node while the leg rig is in either IK or FK modes, you'll see these work fine. If you try scaling the rig in FK mode, you can see this is also taken care of. The only real problem is when you scale in IK mode. The leg scales disproportionately. This is happening because our shin and thigh scale calculations aren't taking the root scale into account. We'll fix this just as we did for our torso and neck rigs by using a multiply divide node. Select the left leg no-flip IK length and left leg PV-IK length shape nodes, the no-flip and pole vector joint chains, and display their connections in the node editor. Create two multiply divide nodes named global scale left leg no flip normalized div and global scale left leg PV normalized div. Feed the distance measurement of the respective legs into the input 1x of both nodes. Also feed the scale y of the root transform into the input 2x of both nodes. Make sure to change their operations to divide. Now connect them each to the input of the shin and foot driven key animation nodes that determine the length of each portion of the leg. Now if you scale up and down, the leg scales properly. Now we're ready to lock and hide any extraneous attributes. Lock and hide all the transform attributes and visibility attribute on the left leg settings control. Also lock and hide the scale and visibility attributes on the left foot control. On the left knee control, lock and hide everything except for the translate and knee snap attributes. And on the left knee group, lock and hide everything. Switching over to the FK controls, lock and hide everything except the rotate attribute on all the controls, as well as the length attributes on the thigh and shin. Now animators can only modify what we want them to modify. That completes our checklist, which means we're now finished with the leg. In the next movie, we'll begin tackling the IK foot rig.